This video covers more advanced concepts that will mainly be useful for those studying higher levels of trigonometry. To get the most out of it, you should already be familiar with the trig ratios, sine, cos and tan, and how to use them. But let's recap the important considerations. In basic right-angled triangle trigonometry, the trig ratios are defined in terms of a pair of sides relative to one of the two acute angles. For a given sized angle, such as 30 degrees, the ratio for a given pair of sides remains constant, no matter how big or small the triangle. This is due to simple similarity, with all right triangles containing that angle being similar to each other, and thus the ratio of any pair of sides will remain constant. This is why we give special names to the three possible pairs of sides. The opposite side over the hypotenuse is known as the sine ratio, abbreviated to SIN, but still pronounced sine. The adjacent side over the hypotenuse is the cosine ratio, or cos for short. And the tangent ratio is the opposite side over the adjacent side, abbreviated to tan. These ratios can actually be defined beyond acute angles in right triangles, and you'll learn about this when you continue your studies into further trigonometry. For convenience, we can label the vertices of our triangle A, B and C, like this. And, following geometric naming conventions, we label the sides opposite to them with the lowercase equivalents. This enables us to write expressions for our three ratios. So we have sine theta equal to A over C, cos theta is B over C, and tan theta is A over B. Since we have a right-angled triangle, then the two acute angles must be complementary, making up the remaining 90 degrees of the triangle. And since we have labelled angle A as theta, then angle B must be 90 take away the value of theta. We can now write expressions for the trig ratios for 90 minus theta, which is the angle B in the triangle. Switching to angle B means we need to label the sides with reference to angle B, not A. This results in the opposite and adjacent sides swapping with each other. Reading our ratios, we see that the sine for the complement of theta is B over C, which is identical to the cosine for theta. This is quite literally why it's called cosine. Rather than having its own unique name, the cos stands for complementary. Cosine means complementary sine. They are clearly connected. Thus, as expected, we find that the cosine of 90 minus theta is the same as sine theta, being A over C. To clarify further, because cosine is complementary to sine, its ratio values are identical to the sine ratio of the complementary angle. Any two angles that add up to 90 degrees will have identical values when comparing the sine of one to the cosine of the other. For example, sine of 10 degrees must be the same as cosine of 80 degrees, or cosine of 60 degrees must be the same as sine of 30 degrees. And so on. What about the tan ratio for 90 minus theta? We find that the tan of 90 minus theta is B over A, which is actually the reciprocal of tan theta. If you multiply them together, you will get 1. Testing this on the calculator, we see that tan 10 multiplied by tan 80 is indeed equal to 1. And this will happen with any pair of complementary angles. Tan 40 times tan 50, for example, equals 1. Following the same naming convention for sine and complementary sine, in other words cosine, the complementary tangent ratio is known as cotangent, or cot for short. We know the tangent ratio is defined as the opposite side over the adjacent side, so the cotangent ratio is defined as the adjacent side over the opposite side. Clearly, this is also the reciprocal of tan theta. We can include these results with our other complementary results. The sine of the complement of theta is identical to the cosine of theta. Likewise, the cosine of the complement of theta is the same as the sine of theta. and the tangent of the complement of theta is equal to the cotangent of theta. Further, it's also equal to the reciprocal of tan theta. And finally, the cotangent of the complement of theta is identical to the tangent of theta, and it's also the reciprocal of the cotangent of theta. The true benefit in knowing these relationships won't become evident until you encounter more advanced topics in trigonometry. But for now, be aware that these expressions are completely interchangeable. For example, if you are using sine 50 in a calculation, it can equally be replaced with cos 40. Or if you encounter cot 30, you could replace it with tan 60. Note that the relationships are expressed in terms of degrees. They can also be expressed in terms of other angular measures, which you will learn about in your further studies of trigonometry. Let's try some typical exam-style questions that might be asked to test your understanding of these concepts. Pause the video if you'd like to try them on your own first. Example 1 is the straightforward case. Cos x equals sine 70. We know the angles must be complementary since cosine equals the sine of its complement, and vice versa. Obviously, x must be 20 degrees. There are various ways you can communicate this. X must equal 90 minus 70, which equals 20 degrees. Or we could write cos x equals sine 90 minus x, which equals sine 70. Therefore, 90 minus x equals 70. 90 equals x plus 70, leading to x equals 90 minus 70 as before. This technique might be useful in more difficult cases. Example 2 is also straightforward since it's already in the form of our complementary results, namely tan theta equals cot of 90 minus theta. So this becomes trivial. Theta is 40 degrees. In example 3, you will need to solve a simple equation once you establish the correct relationship. We know that sine theta must be the cosine of 90 minus theta, so the 2x must be the complement of the x minus 30, meaning that x minus 30 will be equal to 90 take away 2x. Alternatively, we could have used 2x is equal to 90 minus all of x minus 30. Just be careful here when subtracting the negative 30. The first expression leaves less room for error. Adding 2x to both sides, and then 30 to both sides, tells us 3x must equal 120, so x equals 40. Another approach is to simply remember that if sine and cosine have the same value, which is indicated here by the equal sign, then their angles are complementary. In other words, the 2x from the sine ratio added to the x minus 30 from the cosine ratio must total 90 degrees. Simplifying gets us to the same result, that 3x minus 30 equals 90. So we solve as before to find x is 40. It's easy enough to verify our solution is correct by substituting x equals 40 back into the original expressions. The left-hand side gives us sine 80 and the right side cos 10, which we know is correct since 80 and 10 are complementary angles. If in doubt, you can also confirm they are equal using your calculator.